Hello, everyone. Thank you for coming. It's amazing to see so many people turning out for the first AWS Community Day in Belfast. Really excited to be here. Really happy to talk to you, especially about my favorite, although biased, AWS service, DynamoDB. Before I get started, I have a favor I need to ask of all of you. This is an interactive session. Therefore, I need you to help me. Otherwise, this whole session will fall on the floor. So it's a long, narrow room. So if you're at the back, make sure you shout really, really loud. Maybe we can test our vocal range. So in the count of 3, let's everybody shout DynamoDB at the same time. 1, 2, 3. DynamoDB. Good. We're all in the same boat. Cool. The other favor I have is my time management skills are shocking. So please, somebody keep a time for me. So once my 30 minutes is up, just start booing me until I get off the stage, because I will just stay here and talk forever. Good. My name is Lee Hannigan. I am a Senior Specialist Solutions Architect with DynamoDB. I've been with AWS for 5 years, just over 5 years now. And I am based out of Costa del Donegal, if you've all been on holidays there. So in this session, we're going to talk a little about design puzzles, or more specifically, questions that customers brought to me with problem statements and they needed help in coming up with a solution. I'm now going to share the problem statements with you, and I need you to help me solve those problems. We're going to start with amuse-bouche, and if most of you are probably on the same salary as me, you probably don't know what amuse-bouche is. McDonald's don't happen to do amuse-bouche, but it's appetizers, so we're going to start with a couple of introductory problems. Then we're going to look at a more complex one, which is design redemption code, so I'll get into that when we get there. And the last one is going to be how we can look up metadata for IP address ranges. So we'll get started. We'll start with amuse-bouche. So the first one is, my on-demand table is very slow to load some initial data. Sorry. Small stage. So it's very slow to load initial data. I moved to provision mode, and it happened to get much faster. Does anybody know why provision mode was better? Nobody? Do you think provision mode is more performant? Are you familiar with, hands up who uses DynamoDB or who is familiar with DynamoDB? Okay, so you're familiar with the capacity modes, on-demand versus provision mode. Do you think there's a difference in performance on the two?
Provision keep like a minimum capacity.
Okay, provision keeps a minute of capacity, okay. Anyone else? No? So what happened here is that with on-demand mode, we come up with an idea that we think that we give everybody probably a fair start, or at least fair to us. So what we do is we give you the ability to make 4,000 write capacity units, or consume 4,000 write capacity units, or 12,000 read capacity units. We thought when you create an on-demand table, that's a nice sort of nice starting number. But if you start with an on-demand table with the capabilities of doing 4,000 write capacity units per second, but you want to instantly scale, so you create a new table and you want to drive traffic into it, you have a big data dump, you want to ingest all of your data from maybe another database or another system into DynamoDB as quickly as possible, you're going to hit this 4,000 write capacity unit limit, and what happens is you get excessively throttled. What happens is that many people think that DynamoDB is not all that everybody says it is. It can't even take a data dump. But the problem is that you didn't understand that you've only got the initial capability of 4,000 write capacity units. So this customer flipped to provision mode, and they knew they needed about 10 or 15,000 write capacity units. So that's what they provisioned. Under the hood, DynamoDB scales out, says, okay, this customer needs 15,000 write capacity units. We'll create 15 partitions under the hood. Each partition can give you 1,000 writes and 3,000 read capacity units. So they naively thought that provision mode is way more performant, but it's just an actual fact that they told it to give me the capability of 15,000 write capacity units, whereas the on-demand was starting with 4,000. Now, don't get me wrong, The on-demand would scale eventually, and we'll see that a little later. But out of the bat, it will only give you 4,000 write capacity units. To overcome that, you can do this thing that we call pre-warming. I'm sure many of you are aware of the concept of pre-warming. In DynamoDB, pre-warming is that you create the table in provision mode. Let's imagine that you think in the future you're going to hit, let's say, 40,000 write capacity units. You provision it to 40,000 write capacity units. Then you flip it back to on-demand. DynamoDB does not merge partitions. So once you scale out, you're forever scaled out. You don't pay per partition. You pay for what you consume or what you provision. So you've told it to scale out to 40,000 write capacity units. You flip it back to on-demand mode. You will forevermore have the ability to go from 0 to 40,000 write capacity units instantly, so long as your key value or your access patterns are well distributed. Good. So I'm looking at a table with a lot of write traffic, but 0 read traffic. So a database with a lot of writes and 0 reads. Why would anyone have a table that they never read from? And my initial assumption here was that if you never read from a database, then dev null is a really highly scalable and efficient database. So anybody, any concepts of what was going on here?
A log.
A log? Can you explain?
Maybe they were dumping a list of changes that they were making into every table. They were applying it to other data, but on that table it was just a dump.
Okay, yeah. So, for example, a not log where maybe you don't read from it all the time. Maybe you just want to read from it when something goes wrong, for example. Maybe once a month, or hopefully never. Hopefully never anything goes wrong. Yeah, that's one good example. Yeah, anything else?
Are they streaming it somewhere else?
That's another really good use case. So DynamoDB has change data capture, which is all of the log of all of your changes that happen on a table. So you make your writes to DynamoDB. You can consume those changes, for example, through a Lambda function, and you might push that data downstream somewhere into a different system, for example, OpenSearch or Elasticsearch, something like that. So maybe the reads are happening in another system, but DynamoDB is handling that high velocity of write throughput. Yeah, another good one. Not what was happening here, but two really valid use cases. What was happening here was this customer was using DynamoDB as a session store. And you would imagine that you would have to read session state, but when you make an update to DynamoDB, you can implicitly ask for it to return that data. So let's imagine it's a session store and you want to update a user session that you give them another 24 hours access, for example. When you update that timestamp to allow them for an extra 24 hours, you can actually tell DynamoDB to give you back the item as it is when you made the update. So you get all of the other metadata for free, essentially. It's a free read. So when they were using it as a session state store, they were updating a timestamp, but at the same time, they were getting back all of the metadata they required to fulfill that user session. So that was what's happening here. So my initially thought when they were doing no reads is, I can save you money here. Let's just drop the table. You don't need it. But once you get into it, there is valid use cases for such a scenario. Cool. Now let's go into a little bit more of a meaty one, and we're going to talk about vending redemption codes as a service. An easy way to explain this is that if any of you're looking at the audience here, most of you are around my age or maybe older, you remember Pepsi bottles or Coke bottles where you got a label that had a code and you vended that redemption code, see if you won anything. Now it's important that only one person is ever the winner. You don't want to double vend a code. We'll get into that in a second, but let's imagine that you're doing vending codes as a service. So our partition key is a marketing ID. So depending on, is it a Pepsi campaign, is it a Coca-Cola campaign, or whatever other sort of company is running a campaign. We can have many thousands of campaigns at any one stage. Within a campaign, we have a sort key, which is that unique identifier or token. We can have many millions of tokens for each campaign. And you want to only vend one. They have to be unique. So we need to figure out a way how we can safely vend these tokens. So first of all, we want to do an atomic get and a delete. So how would you get and delete one of these redemption codes safely in DynamoDB? Any ideas? Transaction, yeah. So if you've done a transaction, the thing is with a transaction, you can't do a read and a write in a single transaction. You can only do writes. So the write here could be a delete, for example. But in DynamoDB, all singleton writes are already serialized, hardly serialized on the actual physical server. So a single delete is basically has transactional guarantees around it already without having to use transactions. I have a hint here. It's an air conditioner. So I'm hinting here at a condition. We can use a condition check. So let's say that I first give you the code that you want to vend. So let's forget about the reading part of it for now. I give you the code, you want to vend it. This is an example of how you would do that. You would delete the item from DynamoDB with the condition that that item still exists in the table. If it exists, you get a 200 response. You won. You were the only person that vended that code. If you tried to vend that code and somebody beat you to it, you would get a condition check failed exception. Then you would have to go back, get another code, and retry to delete it again with the same condition that that item exists. So that's one way to make sure that there's only ever one winner to vend a code. But that leads us to the next challenge is, how do I safely decide on an item to get? When I first talked with this customer, their idea was, we'll just read the first one. Anybody see anything wrong with reading the first item? So the query looks something like this, where you do a query, you give it the campaign ID, and you take the first item. We're limited to one, so it's the first item for that campaign. Does anybody see a problem with that?
You should use a strong, consistent read.
Strong, consistent read, yes. That can help. My problem here is that everybody is going to try read the first one. So you're going to have a huge race condition depending on the throughput of your system. You have lots of people trying to vend that code at the same time. They're all going to read that item at the same time. There's only one winner. So you have a lot of these conditional writes to delete the item, and most of them are going to fail. They're going to fail, and when you fail a condition write, you still consume capacity. So your write capacity consumption is going to be quite high, and your user experience is going to be degraded because they're all going to be retrying, trying to get the next one, delete, and they're all racing one another to get that item. That race condition is probably not something that we want. So what about pulling n items? So here I say, I define n. I'm not going to tell you what n is. I want you to tell me what n is. But I get n items, and then I return those items to the user, and they can pick one from that batch of n. What should n be? Should we read 1,000 items and pick one randomly? Should we read 10? Let's imagine it's a, I don't know, a 40-byte item. Any ideas? Read consumption in DynamoDB, you read up to 4 kilobytes. So you can have a strongly consistent read of 4 kilobytes, and that will cost 1 RCU. So what you want it to do, if you do it this way, you want to read enough items that it doesn't spill over to the next 4 kilobytes. So we could read up to 100 items here if they're 40 kilobyte items, and we could pick a random one, and we would still pay the exact same cost as we read just one item. So we get 100 for the exact same cost. Performance, it could be microseconds in difference. Nobody will ever notice a performance difference. But I'm a perfectionist. I want a true, unique one item. I really just want one item. And the way we can do that is by playing with the sort key. So as we know, the campaign ID is our partition key, and we have many millions of items in our sort key. So what we do is we generate a random prefix. So let's say just 3-character string. And we tell DynamoDB, for this campaign, start reading from this random string. That string does not have to exist within the sort key. It's just a pointer to a position on disk. Say, from this point, read forward, get one item. And that's exactly what we do here. So everybody has a random chance. There's only one caveat to this, is that if you happen to pick a random range that ends at that falls in the end of your sort key, you would get returned no items, which would lead you to believe that there's no items, but it's the fact that you started at the end of the range. In that case, if you got returned no items, you should read in reverse order as well. So you should read forward first, which is by default ascending order. If you should get no items, you should try and read in descending order, which is back up the stack, just to make sure that there is no items left to vend. Cool. So what if I wanted to keep an audit log of all of these burn codes? So maybe we have a use case that we want to go through all of those codes, the time, for example, that they were vended. How could you do that?
DynamoDB streams.
DynamoDB streams, yeah. DynamoDB streams, we can capture that delete change, and then we can either store it in S3, for example, if we want long-term retention with cost-effective storage, or we can store it in another DynamoDB table that we might drop after 30 days or once the campaign ends. Anything else? We could use transactions. The problem with using streams is we delete the item, but we never say, or we can't say who vended that item. We can't say which user efficiently vended that item. We know the timestamp it was deleted. We know that the item was vended, but we can't say who won it. So if you had two users coming to you to say, I vended the same code as this user, how do you know which one actually won? With transactions, we can do that. So at the same time we delete an item, we also place an item in a second table, and we can put the user information in there. So whatever user ID, let's say Lee, vended this code, in our audit table, we'll have that code and my user ID assigned to that. So then when two users come to say to you, hey, I vended that code, then we can look at our second table and say, Lee was the winner of that code. We don't know how you got that code, but we know for a fact that Lee vended it because it was in an atomic transaction. Cool. So let's look at IP addresses. This is a little bit more of a complex data model, but it sort of shows how DynamoDB can scale. I'm going to read this one out from the screen because I can't remember it offhand. So imagine you want to look up metadata about the incoming IPv4 addresses. It's the metadata that's associated with it, such as owner, country of origin, security rules to apply, and many more. So your metadata is made up of 500 unique IP address ranges, each of them having a start and an end address, as well as the metadata payload to be returned to the IP address for that range. Sounds a little complex. Does anybody know how we would start to even model this? Let's take a look at the algorithm that went through my head. So first we have to assume that we want non-continuous overlapping ranges. That was the first thing we needed to set out. Second, we want the ability to do it in a single query. We don't want to make multiple queries to DynamoDB to get a range of addresses. The third was, what sort of value should be used as the sort key and what data type? And more importantly, what should we use as the partition key? We know that DynamoDB likes high cardinality partition keys, meaning a partition key that has many, many values. You don't want to set a partition key of a static value or a status, for example. And we'll see why in a second. So, contrary to popular belief, I went about it in the fashion that I probably shouldn't have, and I started out with this data model, where I had a static value of 0 as my partition key. I then had the range in the sort key, which was the dot notation of the IP address, stored as a string. Can anybody spot a problem here?
You can't do a search
I can't do a search?
between the values inside the range on a string. You have to parse that into a value in check. So it's like your index falls inside the range.
Okay. Anything else? My biggest problem here was that strings sort lexicographically. 10 comes before 9. So my sorting order would be really messed up here. The ranges wouldn't work for me. My second problem was I was silly enough to use a single partition key, which limits me in DynamoDB, if you remember. Each single partition in DynamoDB can give you 1,000 write capacity units. Using a single partition key, I've limited the scalability of my table to 1,000 write capacity units and 3,000 read capacity units. We'll talk a little bit more on that later. But to fix the more pressing problem was my sorting. So we store IP addresses as dot notation just for readability. We store it into a decimal format as a number type. We can still sort in it. It's not as easy to read, but it's definitely more efficient for sorting. We could, of course, zero pad it, the dot notation string. That would have worked. But this is much nicer. It's cleaner. Numbers are more compact. If you had millions of them in your table, it would take up less space. Performance-wise, probably doesn't make any difference. This is what we went with. So, any ideas on how I can overcome my scalability challenge? 0 is not really a good idea as a partition key. My idea here was to take the first octet in the range as the partition key, because you're going to know the first octet when the user is looking for the range of that IP address. This gives me about 250 odd unique IP addresses, or unique partition keys, should I say. Scalable, yeah, I can do approximately 250,000 writes per second. Probably good enough for what I need it for. 3 times that for reads. So this was a win, I suppose, in my case. Depending on your needs, you could use the first 2 octets, depending on what way you look up those metadata ranges. So I've set, I think I have my data model, so I'm going to go in and do some load testing with that data. So we're going to look at the speed. I'm going to go back to the way I had it in the beginning. Everything that DynamoDB tells you not to do, I'm going to use 0 as my partition key, and I'm going to use that number range as my sort key. I'm loading a CSV file with my 500,000 IP addresses into DynamoDB, and this is my consume capacity. I'm getting exactly 1,000 write requests per second. Why? Partition key, yeah. I'm using a single partition key, 0. Hitting partition limits. I'm getting exactly 1,000 writes is what one partition guarantees me. Everything else after that has been getting severely throttled. So I move forward, I say, okay, let's go back to the one where I have 250 IP ranges. And I loaded the data again. I thought I had a nice, it's not high cardinality, but it's a lot better than just one. I get this, roughly about 1,300 write capacity units per second. Why is this happening?
Your IPs be skewed with your keys are all over.
Exactly.
You use the last octet.
Yeah. My CSV file is ordered based on the IP address range. So I have induced something that we call a rolling hot partition. We start out with IP address 1, and we get limited to 1,000. Then we move to 2, moves to another partition, still limited by 1,000. So every time that change happens somewhere in the middle, we get a little bit extra. How do we fix that? We shuffle it. We just take our CSV file, we shuffle it, so every write that we put into DynamoDB is somewhat random. It's 250 unique partition keys. And it ends up looking something like this, a lot better, probably not the scale that I expected. I'm hitting 4,000 write capacity units per second. Why? Who was listening? It's on demand, brand new table. I have a high watermark of 4,000 write capacity units per second. I haven't pre-warmed this table. If I had have, I would have got a lot more throughput. That's what's happened. So I'm hitting that 4,000 limit of an on-demand table. If I pre-warmed it much higher, I would have got much higher throughput. So let's look into reading the data. So we're back again with just the single partition key because I really want to test the capabilities of a single partition key. How many queries per second? Let's take a look. We're consuming 4,500 request or RUs, which is the same as RCUs, which is read capacity units. Which is essentially we're doing, because we're doing eventually consistent reads, we're doing 9,000 queries per second. Okay, I told you a single partition can only do 3,000 read capacity units per second. Why am I getting 4,500?
Because reads happen in replicas.
Exactly. Then would we split your data into 3 availability zones. So we have 3 copies of your data. If you do a strongly consistent read, you'll always read from the leader, so one of the availability zones for that partition. But if you do an eventually consistent read, you can go to any one of the 3. That allows me to consume more than DynamoDB says that I'm allowed to consume. So I'm getting about 50% more throughput because I'm reading from the replicas. They're not, yeah, you can call them replicas, but eventually consistent read goes to any one of the 3 partitions. So initially I'm getting 4,500 RCUs because I'm reading from each one of the 3. Here's what happened after a couple of minutes. I went from 4,500 RCUs to 9,000 RCUs. Why did this happen? Yeah, this is something we know as adaptive capacity. That single partition we had, because we were using one single value of 0, became hot. After some time, that partition raises his hand and says, hey, I'm hot, DynamoDB, help us out. And what DynamoDB does, it takes that hot partition, it does some heuristics, and it picks a split point, usually in the middle, depending on your access patterns, but usually in the middle, and it will split that partition into 2. At that time, we can now consume twice the capacity. We had 50% of partition key 0 in one partition, and 50% of partition key 0 in a second partition. The sort key is the ranges between the 2 partitions. So we get double the throughput, which is nice. But then after some more time, it goes like this. And this is easy to explain. We had one hot partition, it split into 2. We had 2 hot partitions, it splits into 4. So you can see how things happen over time. So contrary to popular belief, a single partition key can give you some scalability, although you would be surprised at how much I got throttled when I ran this. Now, this is the conundrum. Can anybody make heads or sense of what happened here? Anybody like to take a stab at this? It's a strange one. I'm not sure many of you have seen this graph or if you've hammered DynamoDB so hard that you see something like this. I like to start on the right-hand side and work back when I'm trying to explain this. What I didn't say is that I have 80,000 read capacity units as my account table limits. So in DynamoDB, you've got limits at the account level and the table level. Mine's happened to be 80,000 RCU. 80,000 RCU strongly consistent. I'm doing eventually consistent, so I get the extra 50%. That explains why I'm hitting 120,000. Now working back, we can see we had peaks of 225,000, which is way beyond my 80,000 limit. If we come back before that again, we can see that we were splitting over time. And DynamoDB has a concept of burst capacity. So any capacity that you don't use, so any capacity under the 80,000, DynamoDB stores that in a token bucket. And when you want to exceed what you've got provisioned, or in an on-demand mode, if you want to exceed what your high water mark is, you can dip into that token bucket. So on the left hand, all the way over to the right, we were being hit or throttled by the partitions that we had to physically give us the capacity. Once we got to a point somewhere here in the middle, we had enough partitions to give us the amount of capacity that we needed. We went above the 80,000, or eventually consistent read, the 120,000 limit. We went above it for a short time because we got to dip into that token bucket, that we were saving that excess capacity for a sliding 5-minute window. So we got to dip into that bucket until we exhausted it. And at that time, we were now bound to our account limits. We had enough partitions to give us much more capacity, but we were bound by the limits of that 80,000 RCU eventually. So here's a mix of adaptive capacity working and also burst capacity working in the middle, where it allows you to go above what you've provisioned for a short duration of time. And that's really useful for handling spikes in traffic that are unprecedented or unpredictable. So is there any advantage to having a high cardinality key? I showed you the capabilities here of using one single partition key. We could get upwards in 225,000 RCU, which in queries per second is double that. What's the advantage of using a high cardinality key?
Scales up faster.
Scales up faster. This was my hint. Didn't need the hint. But what I have here, if you can tell clearly, is we have one really, really hot partition and 3 really, really cold partitions. So the one hot partition is the only one that we acted on with a single key. The rest of them remain freezing cold forever. We kept splitting the hot one slowly over time. If we had to have just evenly distributed across the 4 partitions, then we would have split all 4 of them at the same time, and that would have looked something like this. See how much quicker I can go through when we're splitting 4 partitions at a time, rather than waiting for 1 to split. So I hope you enjoyed the deep dive into DynamoDB. It's a different way of looking at it, and if anybody has any questions and wants to talk deeper in DynamoDB, or you have some questions, please come and let me know. Thank you.